Hey guys, welcome to Infinity Junction. This is Vivek. So today we are going to discuss about equations reducible to quadratic equation part 2. In part 1 we have discussed about standard form of equation and what are those equations which are reducible to quadratic form and how to solve them. In this video we will see the next form of those equations which are equation involving product and quotient, and we'll see those type of equation with examples. So let's get started. So equation involving product and quotient first include 2 points here. If the product of two or more number is 0, then at least one of them must be 0. What it means, if p dot q is 0, then either p is 0 or q is 0 to make this whole thing as 0. And the second point is, if the quotient of the division is 0, then the dividend must be 0. So if the quotient of this division is 0, then the dividend must be 0. So in this case, p is equals to 0 or q not equals to 0. So these are the conditions. If p by q is 0, if and only if p is equal to 0 and q not equal to 0. Okay, so let's see an example. So here first example is x square minus 1 dot x square minus 2x minus 8 equals to 0. So these are the two equations. So this, let's say this has p and this has q. So if you solve this, then either p is 0 or q is 0. So if you factorize this x square minus 1, then it will come up with x minus 1 and x plus 1. If you solve this and factorize this, then it will come up with x minus 4 and x minus 2 as a factor. So to make this whole, if the product of this is 0, then at least one of them must be 0. Okay, so you have to check those equations. So the roots of the equations are minus 2, minus 1, 1 and 4. So this is the way to solve those type of equations. Now we'll see in second example. So if x square minus 4x plus 10 dot x square minus 5x plus 2 equals to 0. Now these are two quadratic equations in p in dot q form. So let's try to solve it as two different quadratic equation. Now if you solve this p as x square minus 4x plus 10 equals to 0, then the discriminant is minus 24, which is clearly less than 0. So it has no real root. Now if you solve x square minus 5x plus 2 equals to 0, and here discriminant is 17. So by quadratic formula, if you find the roots, then alpha is 5 minus root 17 by 2 and beta is 5 plus root 17 by 2. So these are the solution to the equation of this. Okay, now we will see another example. Here x square minus 5x minus 6 is divided by x plus 2. Now this is p by q form. So here q not equals to 0. Here q is not equals to 0 and p must be 0. So denominator is not equal to 0. Therefore x plus 2 is also not equals to 0. And x here is not equal to minus 2. This is minus. And if you solve this p quadratic equation, x square minus 5x minus 6 equals to 0, then you will come up with two roots alpha and beta as minus 1 and 6. So minus 2 is not a part of the solution, and this alpha and beta are only the part of this equation. Okay, now here is a very important remark. Here is, it is very important to check the numerator to see whether they make the denominator 0 or not. We can do this by two ways. So if the equation is p by q form, if the equation is in p by q form, then it is very important to check the roots of this numerator to see whether they make this denominator 0 or not. So we can do this by two ways: by substituting the roots of the numerator in the denominator, or by finding the roots of the denominator directly and check whether they are common to each other or not. So let's say an example here is x square plus 7x minus 8 is divided by x square minus 3x plus 2 equals to 0. So if this is p and this is q, so if you solve this, then q not equals to 0 is the first condition. Therefore x square minus 3x plus 2 not equal to 0, and here the roots are x is not equal to 2 and x is not equal to 1. And if you solve this equation, x square plus 7x minus 8, so you will come up with this x equal to 1 or x equal to minus 8 are the only roots of the numerator. Now see if there is any common root. So as we know, x here x equal to 1 is common in this p and q. Now this is not a part of the solution, so the only solution left is minus 8. Okay. Now here is another example. 4 by x plus 1 minus x plus 1 by x minus 1 equals to x square minus 5 divided by x square minus 1. Now this is not in quadratic form. So first you have to make it quadratic. So how you can make it quadratic? So you can make it quadratic by multiplying each side by x square minus 1. So if you multiply each side by x square minus 1, then the equation will become like this. 4 times x minus 1 minus of x plus 1 whole square equal to x square minus 5. Now here d is, if you take LCM and find, then the d is x square minus 1 is not equal to 0. So x is clearly not equal to plus or minus 1. Now if you solve this equation, then you will come up with two roots as x1 equals to 0 and x2 equal to 1. So x is not equal to plus or minus 1. So 0 is the only solution of this equation, because x equal to 1 here is x equal to 1 second root, and here the condition is x is not equal to plus or minus 1. So the only root left is x1 equals to 0. So this is the only part of the solution. Okay. So this is all about equation involving products and quotient. We will see equation involving radicals in the upcoming video.